Hello everyone. In today's video I talk about why the data encryption standard DES sucks and why it is no longer used. Before you watch this video, I highly encourage you to watch the previous videos on symmetric encryption and Feistel networks. You will be able to follow this video much more easily if you do. Moreover, the video on cipher modes of operation might also be interesting for you. DES has been selected as official encryption standard for the United States by NIST in 1977. DES is a Feistel network that operates on block sizes of 64 bits. The key size is 56 bits. The difference to 64, the 8 bits, are the parity bits that are used for validation. DES allows the modes of operation ECB, which is not really a mode of operation, CBC, CFB and OFB. Again, I refer you to my video on modes of operation if you want to know more about those. The algorithm consists of 18 steps, but 16 out of them are just iterations of the same thing. This is the 64-bit or 8-byte plaintext we want to encrypt. First, the bits get transposed after a certain rule. That means that certain bits change places within the block. Next, the 16 iterations start. The block gets separated into a left and a right part. We ignore the left part for now. The right part gets expanded with 12 bits to reach 48 bits. From the original 56-bit key, 16 48-bit keys are derived. Each is used for one round of these iterations. Let's assume this key here, which has 48-bit. During each iteration, the right side gets XORed with the round key, in this case, resulting in that. Now 8 S boxes are applied. Those S boxes have 6 input and 4 output pins. Note that the graphic here is oversimplified since it wouldn't be very clear to have an S box with 64 output in between. However, let's look at how it roughly works. You use the first 6 bits as input. They traverse through the S box and output, for example, these 4 bits. This way, the expanded 48-bit block becomes a 32 block again. Now a P box is applied, which, as you remember, means that the bits are permuted. Next, we take our original left-hand side and XOR it with the result of the permutation. These 5 steps are the Feistel network that is used in DES. It is applied 16 times, 8 times with both sides, left and right. To finish the algorithm, we swap the original left side with the right side, apply the inverse of the original transposition from step 1, and finish the resulting ciphertext. You might ask yourself now, why does DES suck? The answer lies in the key length. If an attacker would attempt to break DES encrypted systems with a moderately fast PC, he could try 1 trillion passwords per second. If we use a 56-bit key, that means that it would take him around 20 hours to crack DES. This is far from being secure. To mitigate this, triple DES has been introduced. It is the same algorithm but applied 3 times in a row with 1, 2 or 3 different keys. That way it stays compatible to the original DES but also allows a much more secure encryption with key lengths up to 164 bits. Now the same attacker would need over 11 nonillion years to crack triple DES. You're pretty safe for a while. That concludes today's video. Thanks for watching. Tell me in the comments which other technologies suck and you want to know why. If you enjoyed the content and learned something today, consider subscribing to keep the videos coming. See you in the next.